Okay, example 1, graph the following quadratic relations. The first relation is y is equal to 2x squared plus 8x plus 5. The first step is to find the x-coordinate of the vertex, and we're going to use the formula negative b over 2a. B is the coefficient of x, and in this case it is 8. So we're going to sub an 8 for b. And then a is the coefficient of x squared. In this case it's 2, so in the denominator we're going to sub in 2. This gives us negative 8 over 4, or negative 2. So negative 2 is the x-coordinate of the vertex. The second step is to determine the y-coordinate of the vertex, and we do that by subbing in this x-coordinate back into the original equation. So 2 times negative 2 squared plus 8 times negative 2 plus 5, which gives us negative 3 for the y-coordinate of the vertex. So from here we know that the vertex has the coordinates negative 2, negative 3. From the relation, we also know that the y-intercept is 5. That's the value of c, and that is because when x is equal to 0, the first two terms will go to 0, leaving us with 5. So the y-intercept is 0, 5. So this is the information that we have about the parabola. 2 points. One is the vertex, and then we have a point that's going to be to the right of the vertex. So we're going to plot them in the next step, step 3. And I'm going to scale everything by 1s here. Okay, so we have the vertex at negative 2, negative 3 over here. We have the y-intercept at 0, 5. And we know that the axis of symmetry passes through the vertex. And we can see that the y-intercept is exactly 2 units away from this axis of symmetry. So we can find the third point on the other side of the vertex using the fact that parabolas are symmetric. So there's going to be another point that's to the right of, to the left of the vertex that is 2 units away from the axis of symmetry with the same y-coordinate as the y-intercept. So if I go 2 units to the left, I end up here. And that means I'm at an x-coordinate of negative 4. Okay, so now that I've used symmetry to plot this third point on the other side of the axis of symmetry, my last step, step 4, is to draw a smooth curve through these 3 points to get my parabola. Don't forget to put the arrows on the ends. Okay, let's look at another example. We have y is equal to x squared minus 4x plus 7. First step is to find the x-coordinate of the vertex. Again, we're using the formula negative b over 2a. We have the negative, that's part of the formula. B is negative 4. In the denominator, we have 2 times 1, because 1 is the implied coefficient of x squared. And that means we end up with 4 over 2, or an x-coordinate of the vertex as 2. Now we sub this value into the original equation to get the y-coordinate of the vertex. So we end up with 2 squared minus 4 times 2 plus 7, which gives us negative 3. Sorry, positive 3. Okay. Now we know that the vertex has the coordinates 2, 3. We also know, looking at this value of c, that the y-intercept is 7. So 0, 7 would be the other point. And now we're going to plot those 2 points. Again, I'm going to scale everything by 1s here. Okay, so I'm going to plot the point 2, 3, which will be right here. Okay, I'm going to plot the y-intercept at 0, 7, which will be right here. And I'm going to locate a point on the other side of my axis of symmetry. That's the same distance away from the axis of symmetry as this y-intercept. So again, I have two units separating the y-intercept and the axis of symmetry. I need another 2 units in the opposite direction. So this is where the third point will be, and it'll end up at an x coordinate of 4. And now I just draw a smooth curve through those points. And this would be the parabola that represents the relation y is equal to x squared minus 4x plus 7.